Rats could be
Good afternoon,
trained to
Earth. This is
escape
Adam
the
Sturch
water
broadcasting
maze.
from Mushroom Mansion,
The
Taos, New
first
Mexico,
generation found it very
working
hard
on
to
oil
escape.
painting
It took hundreds of
abyssal
trials
light.
before they discovered
Alright,
it. The
today's
next
step is going to be
generation,
much like
it got
yesterday's,
easier
actually
and easier.
pretty
They
much the
made
same.
fewer
I'm going to hit
and
it with
fewer
the
errors.
same yellow glaze,
This
translucent
suggested
glaze,
that they could inherit
to brighten it
something
up
their
and start
ancestors
glowing
had
it out.
learned.
And
This
then
is one
I'm
of the
going to
big
hit some
heresies
more
in
white
biology,
highlights, and
Lamarckian
then
inheritance,
on top of that, I'm going to today I'm going to use some
happen.
Payne's Gray to start blocking in the shadows as well.
And
So
in these Harvard experiments,
here we go.
They were very
Zoomed in a
controversial.
little bit.
And people said, well,
Alright,
obviously it must
turn
be
on my light.
genetic selection because in each generation they must have taken the parents that learned
let's do the
smartest,
aperture.
that learned quickest as the generation parents of the
turn that
next
up a little bit.
generation. So there must have been unconscious genetic selection for smarter rats. So the person who was doing this, William McDougall, professor at Harvard, said, okay, we'll do it, and we'll do it again, but this time we'll select as the parents of the next generation the most stupid rats. So they should make more and more errors in each generation, according to that theory. In fact, these are the number of errors. As you see, the number of errors fell dramatically over time with generations of stupid rats. They should have been going the other way. In fact, the stupid rats were finding it easier and easier to learn this, to escape from this maze. It was so controversial, people tried to repeat it, and they did so in Scotland and in Australia. The Scottish and Australian rats took up more or less where the Harvard rats had left off. And they showed the same effect, that the Australians they got another batch of rats, and in each generation tested rats whose parents had never been exposed to the water maze. They were getting better too. So it couldn't have been a genetic change. So everyone heaved a sigh of relief and said, oh, it's nothing to do with modifying the genes, standard genetic theory is fine, but what they didn't explain was the effect itself. This was left completely unexplained because it didn't fit in. And these data are lying there in the archives and fit perfectly with the idea of morphic resonance. Now, the idea of morphic resonance should also apply to human beings. It should be getting easier to learn things that others have already learned. It should be getting easier to learn to program computers, do windsurfing, skateboarding, any of these new skills that people learn. Most of them are getting easier to do, but of course it could be because of TVs, instructional videos, better designs, new training methods and so forth. So to test morphic resonance, you need to do specially designed experiments. One experiment that I conducted in Europe in the 1990s is, in the 1980s even, one of the first experiments involved puzzle pictures. This is a puzzle picture, as used in this experiment. Now, if you look at it, you may not actually see very clearly a particular image that's hidden within it. If you just look at it for a little while, see if you can see it. I'm going to show you the answer in a moment, and then I'm going to ask you how many of you actually saw that. I know it's going to be a small minority. Now, okay, there's the picture. Here's the answer. There's the picture again. Now, how many people got that first time round? Thank you. It's about, I should guess, about 5%. Well, what we did is we had two pictures like this. We showed one of them on British television to 8 million people and melted the puzzle picture into the answer and back again. So 8 million people got it. Meanwhile, we tested people in Germany who couldn't see British television. And with the two puzzle pictures, the control and the test one, we found that people in Germany found it easier to recognize the test one after millions had seen it in Britain, but not the other one. So this is one of the various experiments that have been done directly to test morphic resonance. Another kind of experiment you've just done, that involves words. Each word has a kind of morphic field. When you read a word, you have a kind of gestalt, a pattern, a form. You don't spell out every word, cat. you just see the word, you get it instantly. That means there's a kind of collective memory for reading words, for real words, but not for false words. If you have the same letters, TCA, for example, it doesn't make a word and you don't instantly get it. It's been found by a number of investigators that if you compare people's ability to remember or recognize real words compared with false words, most people, without knowing they're doing it, can recognize the real words better. You've just done an experiment that involved 8 Greek words, three-letter words. 4 of those 3-letter words that you saw were real Greek words that have been read by Greeks for millennia. The other 4 were anagrams of real words that aren't real words. And the question is, will you have remembered the false words less well than the real words? And we've done tests that show that people can't consciously tell the difference between the real and the false words, people who don't know Greek. But so far, I've done this experiment 8 times. 7 times it's shown a clear, significant positive result. I don't know the results of this. My assistant's going to have many happy hours of marking your answers, and we'll find out the results probably in a week or two's time. But so far, this kind of experiment is giving very encouraging results, that people have an unconscious ability to read languages that they can't read normally, an unconscious ability to recognize real words because of morphic resonance from those who've done them before. One of the very few areas where standard tests have been done over many years, where you can look to see if there's a change in time, is IQ tests. Similar tests have been done now for decades. According to morphic resonance, the scores on IQ tests should be going up, not because people are getting smarter, but because the tests are getting easier. And so I predicted this in the 1980s, but I couldn't get hold of the data from IQ tests. And I was delighted to find that a scientist called James Flynn did actually do this. And he found that in the US, there's been a very dramatic increase in average IQ test scores since the 1910s, right up to the present day, showing a really significant increase. This has been mirrored in many other countries too. IQ tests are getting easier to do, but people are not getting smarter by any other criterion. This is now called the Flynn effect, and it really baffles psychologists. Flynn himself says he's baffled by it. People have tried to explain it in terms of better nutrition, more brain growth, more TV. They've tried all sorts of things, more exposure to tests. None of these explanations really explain it convincingly, and it remains an unsolved mystery. It's just what you'd expect on the basis of morphic resonance. A couple of years ago, my older son, who was then 16, was doing the national examinations in Britain, which we call GCSE, General Certificate of Secondary Education. Everyone in the country has to do the same exams, and of course they do them at the same time. Before the exams, he came to me one day and said, very excited, and he said, I and my friends have just thought of a way of getting better scores at GCSE without any extra effort. And I said, well, that sounds a good idea. What's it based on? He said, morphic resonance. And so I said, well, how did you work that out? And he said, well, one of my friends had been reading your book. Note, he hadn't, but one of his friends. And he said, we were discussing it. We came to the conclusion that if in the physics and maths test, for example, where there are 15 questions, if we do questions 14 and 15 first, and then go back to question 1, 2, 3, 4, we'll be about 10 minutes behind everyone else in Britain for all those other questions. We'll get a boost by morphic resonance. So I said, well, that's a good idea. And I said, well, there must have been some skeptics in your group of friends. And he said, yes, somebody said, what if morphic resonance doesn't really happen? And so we concluded that if it doesn't really happen, we wouldn't lose anything, but if it does, we gain something. So they actually did it. They all did very well, but they're probably smart in the first place. But it turns out this is a very good way of testing it. It also turned out an old friend of mine from Cambridge was in charge of science examinations in Oxford and Cambridge Examination Board. I tried to persuade him to alter the order of the questions for small subsamples of the population to test morphic resonance, to turn our national science exams into a vast morphic resonance experiment. He was intrigued by the idea, but in the end felt he couldn't risk his career on something so controversial. It turns out that in Holland, all exams are done with people at alternate desks have papers in different, questions in a different order. A and B forms of the questions. So one lot do questions 1 to 8 and then 9 to 16. For the other lot, 9 to 16 are called 1 to 8, and then 1 to 8 are called 9 to 16. So people at adjacent desks can't copy from each other. That means in Holland they've already got a huge database of exam results that could be used to test this theory. And a colleague of mine at Amsterdam University, Dick Dearman, has already looked at some of their university exam results and found that in 7 out of 8 papers, morphic resonance, the morphic resonance prediction has come true. There were higher hit rates, higher success rates when people did questions later than earlier. They're now, at this moment, examining dozens more papers from results from Dutch examination papers to see if this effect shows up. This also applies to crosswords. It should be easier to do the New York Times crossword from tomorrow, than it was today. And some tests have been done to test this with positive results. So this is a very testable theory. It leads to the idea of collective memory, and the idea of a collective human memory is, of course, not a new one. It's been around for a very long time. Jung, the psychologist, suggested we all tap into a collective memory. And I'm saying the same thing, only I'm saying it's just part of the way the whole of nature is, the way all species are, not just the way that humans are. There's one final implication that's particularly mind-boggling. Well, there's many implications. I only have time to mention one of them. And that is this. If morphic resonance depends on similarity, and we have a kind of collective memory from past members of the human species, then the first point is we'll have a more specific memory from people who are more like us, members of our own families, for example, and our ancestors. So there'll be a more specific memory from our ancestors. But then if you ask, well, who in the past is most similar to me? The answer is me. Each of us is more similar to ourselves in the past than to anybody else. That means that the most specific morphic resonance acting on any one of us is going to be from our own past. This self-resonance means that we can resonate with ourselves in the past, and our memories can be transferred by morphic resonance from our own past. I'm suggesting that memories are not stored in the brain, as commonly assumed, but rather occur through self-resonance with our own pasts. Our brains are more like TV receivers than video recorders. We tune into our pasts when we recover memories, but they're not stored in the meantime in the brain. Because most scientists take the materialist theory of mind for granted, they assume that memory must be in the brain. Where else could it be? It's simply taken for granted. It's one of those paradigms, an unchallenged assumption. It turns out, despite more than 100 years of intensive research and the expenditure of billions of dollars on trying to find memory traces in the brain, people have been extremely unsuccessful. People have tried and tried again, but failed and failed again to find memories in the brain. Every kind of theory is being tried. DNA, RNA, protein modification, synaptic modification, phosphorylation of synaptic proteins, and so on. They've all drawn a blank in one way or another. And I think that's because the memories aren't there. You can no more find memories in the brain than you can find memories in your TV set of what programs you watched yesterday. It's simply not the way it works. But this is obviously a radical and, of course, controversial interpretation of memory. But it's a natural extension of the morphic resonance idea. And wherever one extends this idea, it turns up predictions that seem to fit the facts, often in variance to conventional scientific theories. But the memory theory of the morphic resonance memory theory does work, I think, much better than the conventional one. Of course, you can get memory loss through brain damage or through brain degeneration, as in Alzheimer's disease. But that doesn't prove it's stored there. If I came and clipped out random bits of your TV set, I could affect the way it receives pictures or produces sounds, but it wouldn't prove all those sounds and pictures are stored inside the TV set. It would just prove that those bits were important for the reception or tuning, and I think that's true of the brain as well. Well, this gives you a brief overview of the morphic resonance idea. These notions were first put forward in my book, A New Science of Life, much more fully developed in the presence of the past. And I've gone on doing research on this in one way or another ever since. And it has many, many implications in many areas. So this is just a very brief view of some of the main features of morphic resonance. I haven't yet talked about morphic fields and how this resonance is expressed. But before I do that, I think it's time for us to take a short break. And then I'm going to come back to the fields, and then there'll be time for questions and discussion after that. I'm trying to cover a great deal of material this morning, and that means that there's less time for discussion. I know some people here have a lot of questions, and I wish we had more time or more opportunity, but it's a kind of trade-off. And so I'm going to try and tell you something about morphic fields, the extended mind, and some of the experiments I've been doing, and I hope we'll have time for some questions and comments at the end. So the idea of morphic fields is that self-organizing systems have fields which organize them, give them their shape or form, and every self-organizing system has a vibratory pattern of activity. Every atom, every molecule, every crystal, every cell, every human body, all have rhythmic patterns of activity. It's those rhythmic patterns of activity that resonate across space and time. The idea of morphic fields grows out of the idea of morphogenetic fields in biology. I started as a developmental biologist, and the idea of these fields was first put forward in the 1920s to try and explain how developing organisms develop. Genes alone and chemicals alone are not enough. Your arm and your leg have exactly the same genes in them, exactly the same chemicals, but they have different shapes. There's something about developing organisms that acts like a kind of architect's
All right, so
for the organ. And as organs
as you
grow,
see, that kind of
they
brightens
take
them up,
particular shapes.
starts focusing in
And the
some of the
idea is
details on the
morphogenetic
facial
fields,
features, hands and
fields
feet,
concerned with the coming
and
into
blocks
being
in
form,
some basic
morphogenesis,
shadows. Zoom
are,
in and get my pan up.
what shape.
There we go.
This idea has the additional attraction that fields are inherently holistic. Fields
So it's a little
can
better.
come as wholes.
The third
You
or fourth
can't get
layer of
bits
this,
a field.
it'll start coming.
You
into
can't
focus.
have a bit of a gravitational field or a bit of a magnetic field. And if you think about it, this holistic property is a key
Actually,
feature
there's
of
9
fields
minutes
of all
left.
kinds. If you have a magnet,
Might hit
a
the
bar
close
magnet,
with a little more highlighting while
and
it's
you
still
cut
wet.
off the North Pole, you don't get an isolated North Pole.
Let's do that real
What you
quick.
get is two magnets, each with a North and a South Pole. They instantly regenerate a whole magnetic field. And
Maybe.
this was one of the analogies in the idea of morphogenetic fields
Maybe,
right from the
I think.
beginning. And it helps to explain how
No,
living
'cause if I touch
organisms
that Payne's
have the
gray,
ability to heal themselves.
It's going to bring a lot
after
of
damage.
gray tones
These
into it that I don't
these
think I want
fields are
yet.
integrated
It might
and
take a couple of
healing
days for
in
that to
their
dry
effects.
too. That's pure Payne's
In the
gray.
most dramatic
So, okay,
cases,
that's it for
they
the moment.
underlie
That's Adam Sturch
regeneration.
broadcasting from the Mushroom Mansion House, Mexico, working
See,
on
this
oil
is very
painting
different from machines.
Abyssal Light.
If you
Thank you
have
for
a
watching and
machine,
have a good
the
day,
machine's
Earth.
put together with different parts that are designed by an external mind. A human